going to show how to create the scanline effect using Affinity Photo. I originally saw an effect like this in a magazine, but I couldn't figure out how to do it because the procedural textures don't allow you to have overlapping lines like this with just the regular oscillators. So I sort of gave up on it, and then a while later I came back and I started working on it again, and I figured out a way to do it. I'm going to show how I made this effect, but it involves a few steps and it's sort of complicated. This is the procedural texture that I'm using, and you can see I have a single scan line here. I can control a number of different parameters with this, and in order to do this, I also need to use a macro. So I'm combining a procedural texture with a macro. I'm just going to show how to use this. I'm going to leave the scale at 6. The scanner is the most important part. So when I run the scanner, it will move the signal across the screen. And right now I have it set up to not only move up and down, but also to the side. So it's moving to the right a little bit each time and to the side. What I'm scanning is Perlin noise. So right now I have it set to its smoothest, but I could increase the noise content like that and then run the scanner. And every time I increase this by 1, it moves down to a different position in the Perlin noise source. Just going to turn it back to smooth for now. I can control the color with the sliders, and I can make the edge smoother or larger depending on how I set these sliders here. If I want to use this, I first go over here. I do layer, merge visible, and set the first layer to add. Then I go into my procedural texture. I'm going to increase the scanner by 1. If I want to, I could change the color a little bit. And then I have to run the macro. The macro is going to merge visible. It's going to move to the next layer, and then it's going to delete it, and then it's going to set the blend mode to add. So that ran. I'm going to click here again. I'm going to increase the scanner by 1. I'm going to change the color a little bit, and I'm going to run it again. I go back here, increase this by 1. I'll change the color a little, and then run it again. And keep repeating that process until I get the final result that I like. I've got enough of them, and stop and save the image. I'm going to go over how I developed this now. So I'm just going to turn this one off, and I'm going to delete this filter. Turn it on. I'm going to add a new procedural texture filter. I'm going to set it up for red, green, and blue. And I'm going to start with variable v, a coordinate variable, vec2 of rx and ry times a. Usually I would divide by w, but in this case I'm going to divide by h because I'm doing a horizontal scan line. It'll work better if I divide by h. If I was doing a vertical one, like along the side here, then I'd probably divide by w. I'm also going to be using a color, and I want to put that in near the top because I've got to change it every time. So I'll put the color in now. So it's a 3-element vector, R1, G1, and B1 for red, green, and blue. And now I'll add my custom inputs. The first one will be A for the scale. Then I'm going to have a custom input. I'm going to call it D, and this will be for the scanner. And I'll start that at 0. And then I need 3 0 to 1 inputs for the 3 colors. I'm going to set the scale to 6. So to start off, I'm just going to show the Perlin noise. I'm going to start with Perlin noise variable n1 equals Perlin. I'll use perlincubic of v comma o comma s. And then just show what n1 looks like. And I need to add an octave, O. I'll set that up to 7. And then I'll use a slider for the S. That'll be for smoothness, which will make it smooth out like clouds. That's the first step. Now what I want to do is to scan along a line of this noise, and if it's a black value, a 0, I want to make that low, and if it's a white value, I want to make that high. So I want to have a graph that sort of goes up and down depending on this, if this is light or dark. So the first step in that is, instead of using just v, I'm going to use v.x. So I'm just going to look at the x coordinate. I made these relative x and relative y so that I can move this around if I want to. So really here in the scope is exactly what I'm looking for. I'm looking for this sort of cross-section, this height map based on the grayscale of the image. I'm going to smooth that out like that. Next thing I'm going to do is to set up a scanner. That's going to be variable. I'm going to call it oscillator1 or O1 equals OSC of v.y. And I'll just change this to O1 to see what that looks like. So there's my oscillator 1. These are going to be like my scan lines. And so what I want to do is anywhere where it's bright, I want that to be like a white line. And then where it's darker or gray, I want to filter that out somehow. This one is sort of a linear, which is okay. But if I look at the other oscillators, I notice that this osccr oscillator has a really sharp peak to it, and it has a very bright line, and then it fades off quickly. So I'm going to use that one as the oscillator. So I'm going to change this, instead of just OSC, I'm going to add the letter CR to that, and that'll give me this really bright line. So that's going to be my scan line. Now to get rid of the other background information that I don't want, I'm going to use the mapcui function. Mapcui rescales things based on the range from 0 to 1. And I'm going to put in 2 edges. So it's going to be black until it gets to edge 1, and then it's going to quickly go up to white. So I have edge 1, edge 2, and then my osccr function. I'll add the 2 edges as 0 to 1 sliders. Now I can bring them down. And so I have that, I'm thinking of an oscilloscope, a little scan line going across there. Looks like that. Right now it's just flat because I haven't added anything to it, but I'm going to do that next. So what do I want to add to this? I want to add the noise to this. Right in here, I just add plus N1. And there I have it. So I have my scans. Now, the problem is I have multiple scans going across here. So if I increase this, I'll get more and more of those. I'm just going to leave it at 6 for now. I can drag it and move it around a little bit. See if I can find a place I like, but I'll just leave it here. It'd be nice if I could control the height of this. So I'm going to add a variable for that. I'll call it vertical scale. I'm going to multiply my perlincubic up here by B. And so when I bring this down, you go to flat or bring up the perlinhcubic. I notice it only goes up, and really I want it to go in both directions. So I'm going to change this from perlinhcubic to the harmonic form of that function, perlinhcubic. So now it goes up and down around that center line. So at this point, I thought, okay, maybe I could multiply it by another function so that it masks out this one, and then it gets rid of these. So this one is showing, the top one is showing, and the other two lower ones are gone. So to do that, I set up another oscillator. I'll use a variable, call it O2. And if I just do an oscillator of V dot Y, and look at that, it looks something like that. I'm going to add in my O1 to show what that looks like. Okay, so here's my O1 on top of my O2 oscillator. So this one doesn't look quite right. What I want is this to be pure white, and then the rest of these to be black. In order to do that, I'm going to use the step function. So I'm going to step, I'm going to use another edge for this one, and then I'm going to go like that. So when I put in the edge here, I'll be able to control this. And now I can overlap those. I'll call this window height. Now I want to be able to see the function underneath, so I'm actually going to put in another variable. I'm just going to show the window. I'll call this my window. I'm going to show the window. And so when I do this one, I'm going to multiply by J. So I can fade that out, and I can see where my window is. This isn't how I want it, though. I want this one to be white and the rest of it to be black. So right now my frequency is the same as my oscillator 1. I need it to be less than that. I'm going to put in a variable that I can divide out the frequency. So it'll be the period, actually. And I'm going to set that up to 3. And over here on my oscillator 2, I'll divide by C, which is the period of the wave. Period is the inverse of frequency. Okay. So I'm just going to move this one up a little. I'm going to change my window height. And now it looks pretty good. I have my oscillator in the middle of my window. And I have the window just covering that. And so if I now, what I can do is multiply by O2 over here. I can make those other two disappear. And I don't need to show my window. I can take out my window. I'll just leave it on for now. So I've got a window, I've got my oscillator. But the next thing I want to do is to be able to move this. So when I click this scan button, I want it to start scanning. And right now it doesn't do anything. So I want it to move across the Perlin noise function and change as it goes down. It's going to sample another region of the Perlin noise, and this waveform will change. I'm going to create a new variable, D1 equals D times A divided by H. So now it'll be scaled to match the size of the picture. And that'll turn out to work out pretty well for a increment variable. So So I'm going to take this D1 and I'm going to add it to my, I'm going to put it over here in my Perlin noise as a second parameter, and I'll just put D1 in there. When I change D, it changes, although very slowly, so it's taking a long time to go anywhere. I'm going to add a new input, F. I'll call it sample step, because I'm going to be sampling the Perlin noise as I move down. I'm going to set this to 20, and I'm going to multiply my D1 times F. Now when I change D, it changes significantly each time. And I can control it by making this larger or smaller. But I also want it to move down when I'm scanning it. I don't want it just to stay in the same place. I want this to move down. I could have one that just sort of stays in the same place. But for this, I want it to move down and maybe to the side. To get it to move down, I'm going to go to oscillator 1, and I'm going to subtract D1 from this one. So now, when I increase this, it gradually move down. And again, I want it to go faster than that. So I'm going to multiply it by a real value. I'm going to call that horizontal step. I'm going to set that to 20. I'm going to multiply G times my D1 over here. So now, when I click on this, it's moving down. But I need my window to move down as well. Okay, I'll go over to the other oscillator. I will also add, I'll subtract G times D1 over there as well. Okay, so that almost worked. All right, so that doesn't look too good. What I need to do is to put it in parentheses and then divide by the C at the end. I could divide both of them by C, but I'll just put this in parentheses, and I'll take minus G times D1 in parentheses, then to divide the whole thing by C. And hopefully that will line them up. I'm going to set this back to 0, and then I'll increase my scan. I'll do my scan again. Okay, so now as it's scanning, the window is tracking with the scan. I'll set that back to 0. The other thing I might want to do is to move it over to the side. So as it's going, instead of just having it go up and down, I want to have the waveform shift over to the side as it's scanning. So I'm going to put that one in. I'll call it a vertical step size. And H is a system variable, so I don't want to use H, but I will use H. I'll call it H1, and I'll call it vertical step size. And I'll set that one to 20 for now, but I could have it, I could have it either go to the right or the left, depending on if this value is positive or negative. I'm going to put that on the X component of my perlincubic. I'm going to have minus H1 times D1. Now, as I increase my scan, it's also shifting over to this side. The next thing I want to do is put my color in here. So I've already got it set up. All I have to do is multiply by COL for color, and that'll give it the color. And I'm going to give it a greenish color this time. just like a good old-fashioned oscilloscope. The next part is to set up the macro. I'm going to select this layer. I'll just delete this layer. I'm going to Layer, Merge Visible, and change it to Add. Then I'm going to my procedural texture. I'm going to increase the scan by 1. And I'm just going to leave the color unchanged for this example. Now I'm going over to my macro. I'm going to reset the macro. I'm going to record. I'm going to layer, merge visible. I'm going to click this one, select layer 1 above current. So I'll select that. I'm going to delete that layer. And I'm going to change this to add. So I've got 4 steps here: merge visible, set current selection, delete, and set blend mode. Because I'm using a delete function on here, you might want to be careful what your layers are and how you have this set up, because you may accidentally delete something that you wanted to save. So I'm going to stop this. I'm going to go back to my program. I'm going to increase the scan by 1 and then run the macro. Click here, increase the scan. And if you don't remember if you did or not, you can usually tell if you move it around a little bit. Okay, that's the effect. You can get the equation I used in the description for the video. Let me know if you have any comments or questions, and thanks for watching.